Okay, on this page, we're going to practice some of our definitions, postulates from the previous reference page. It says justify each of the following statements using the property of equality, a property of congruence, a definition, or a postulate. If PQ is equal to PQ, then PQ is also congruent to PQ. That would be the definition. And I always abbreviate definition DEFN. That'd be the actual definition of congruence. What does it mean to be congruent? It means that they're the same length. Number 2 says K is between J and L on a line. So if K is between J and L, and we know that JK plus KL is equal to the whole thing, that is the segment addition postulate. And you can always abbreviate these things. I abbreviate addition there. Any line segment is always congruent to itself. Now notice the congruent symbol. So that's going to be one of your properties of congruence. And it's the reflexive property of congruence. And you can abbreviate property of congruence like that if you would like to. If RS is equal to TU. Notice what you've done. You've took RS and you've took TU and you've added it to each side of this equal sign. You had an XY and an XY. XY is equal to itself, but you added RS and TU to each side. That's going to be the addition property of equality. Notice that we're dealing with an equal sign here, so it's not a property of congruence. The addition property of equality says that you can add the same thing to both sides of an equal sign and it stays equal. Well, RS and TU they are the same thing, so we added the same thing to both sides. If AB is equal to DE, then DE would also have to be equal to AB. That would be the symmetric property of, and notice it's equal sign, so that's the symmetric property of equality. Now we do have a property, symmetric property of congruence too, so be careful. If Y is the midpoint of XZ, so you've got line segment XZ, if Y is the midpoint, it says that XY has to be equal to YZ. Well, what is that? That's the definition of what a midpoint is. So the definition of midpoint. If FG is congruent to HI and HI is congruent to JK, so this one's congruent to HI and this one HI is also congruent to JK, so FG would have to be also congruent to JK. That's the transitive. And remember that you have two different transitive properties, so be careful here. Since you're dealing with congruence, that'd be the transitive property of congruence. If AB plus CD is equal to EF plus CD, now what do we do there? To obtain AB is equal to EF, we took this away from both sides. What do we mean by taking away? Well, the only way that you can get rid of plus CD would be subtract CD from both sides. So that would be the subtraction property of equality, since we're talking about equal signs. If PQ plus RS is equal to TV, and RS is equal to WX, then now we have PQ plus WX is equal to TV. So these were identical. All we did was took out this RS and we put in its place WX. Well, why could we do that? It's because that RS and WX is the same thing. So we took that WX and we substituted. That is the substitution property of equality. Next up, number 10, if LP is equal to PN, and LP and N are collinear, then P is the midpoint. LP being equal to PN, okay? It says LP and N are collinear, LP and N, and LP is the same length as PN. By definition, that is what a midpoint is. That would be the definition of a midpoint. And definitions, notice here that they work forwards and they work backwards. They are biconditional statements. We had the definition of a midpoint here, except for it was the other way. Why was the midpoint? So we could conclude that this was true. Well, on this one, we were given the conclusion from the previous one, and we concluded that it was a midpoint. It's because it's a definition, and definitions are biconditional. If UV is congruent to UV, then UV is equal in length to UV. That is definition of congruence. That's what congruence means, that if they're congruent, they're also equal. If CD plus DE is CE, then CD would equal to CE. Well, how can we get this DE? How did we get rid of it and move it to the other side? Well, it was by subtracting. We subtracted DE from both sides, so that would be the subtraction property of equality.